We can use typedef names, types like number, in array declarations, and it works the way you would expect. If I say that number is an alias for int and I make an array of 3 numbers, then in memory I'll have a picture like this. If in contrast I have an array of number pointers, that means that I'm going to have room in memory for 3 pointer values. Each of those pointer values should point to integers. Right? Each element of this array is an int star, so it points off to an integer, which might be actually an array of 3 integers or 2 integers. We don't really know from this type. The total size of memory then is going to be 3 times size of number pointer, which is 8. So that's going to be 24 bytes created by this declaration of A. What if we declare an area t type for area codes to be 3 integers, and then have an array of area t's? That means our array needs to have space for 3 area t's, or each area t needs to have space for 3 integers. So conceptually, in memory it'll look like that, except all of these addresses will be consecutive. So the total size allocated by this declaration of A is 3 times the size of an area t. Each area t is 3 times size of int. So overall that gives us 36 bytes. Just to change the example, since we had both 3's in both places, if an area t is 3 and we only make an array of 2 of them, then of course we need 6 integers, so that'll be 24 bytes. Typedef here is just a shorthand for int of 3, and so we could get the same kind of picture without using typedef. The key is, where are we going to put this 3? And the way to think about it is, we started out with an array of 2 elements, so the 2 needs to sit right next to the A. So even when we get rid of the typedef, the 2 is still sitting next to the A. It's just that each member of this A has space for 3 integers. The C way of writing types and composing them can be a little bit difficult to read, but that's the way you think about it. Right? We have 2 things, A is 2 things, and each of those things has 3 integers. So that corresponds to an array of 2 arrays, each of size 3. Still, it's going to be contiguous in memory, and so it will look like that. So here we have a 2-dimensional array, really. 2-dimensional arrays of integers where one dimension is 2 and the other is 3, and that's the way it gets laid out in memory. We could initialize an array, a 2-dimensional array declared this way. And so since the first index is 2, that means we need 2 things in the overall curly braces. And each of the inner curly braces has 3 things in it. So that gets us the same array that we were drawing pictures of before. And if we say array 1, 0, that means find the 1th element of the overall array, and then find the 0th element of that array. So we should get a 4 out. Right? And another way to think about that is that A1 gives us that second array, the 4, 3, 5, and then we index into it with 0. So if we take A1, which we just saw was that array 4, 3, 5, it's okay to assign it to an integer pointer, because it's a pointer to this array 4, 3, 5. Array of integers and a pointer to integers correspond. It's not the same to say that A is a star star P, though, because this means a pointer to a pointer that refers to integers, and that's not what A is. A itself is just it refers to the first thing here is not a pointer; it's an integer. So even if we had a cast, it's not going to be okay. That would suppress the error message from the compiler, but it's not actually a valid thing to do, because if we try to dereference P0, this 8 is not a good pointer value. On the other hand, we can take A, which is a 2-dimensional array, and nevertheless view it as kind of a 1-dimensional array, a pointer to an integer, because those elements are going to be laid out consecutively in memory.